6.1 explainer, number 41. Well, the 1 kilogram physics book in the figure here is connected to a 500-gram coffee mug. The book is given a push up the slope and released with a speed of 3 meters per second. The coefficients of friction are static friction equal 0.5, and the coefficient of kinetic is 0.2. How far does the book slide? And B, at the highest point, does the book stick to the slope or does it come back down? So our concepts we're going to go over are Newton's second and third law, tension, friction forces, force diagrams, tilted axis, and kinematics. So I drew 2 force diagrams here. So our slope, which is 20 degrees, our friction, it's going to be pointing up because there's a tension pulling it back. There is an applied force, but that's going to be canceled and be equal to the tension. So this is tension is pulling it back, and the friction is keeping from, because if there was no friction, it would just whoosh. We know that there's a friction force. Well, if there was a tension, if there was just no friction, then it would be equal to applied. If there's a friction force acting on it. So we have our normal force, which is just pointing back against the axis, and our gravity, which is pointing down. And for the cup, we'll have our own for the cup, and there's tension force, which is equal to Fg, but there's an acceleration, so we know mass times acceleration is going to be tension minus Fg to get an acceleration, because our system is accelerating. So I wrote our cup is T equals minus M mass of cup G times mass of cup acceleration, which rewrites the tension minus MC mass of cup G. And then for the book, we know it's the coefficient of kinetic friction times mass of book, cosine theta, right? That cosine being, because this is mg cos theta, because if we look at the normal force, what's acting, because we need cos, there's going to be force right here acting equal to gravity, because it's the normal force, minus tension minus mg sine theta, the force of gravity acting back against it. So we rewrite this tension, we know what our tension is, and we rewrite this acceleration, and our final acceleration being negative 4.27 meters per second squared. Then we use our kinematics, because we were trying to find the change in distance. V squared equals VO squared plus 2a change in x. We rewrite that to be negative 9 over 2 minus 4.27, which is equal to 1.05 meters. Now for B, we want to know when it stops moving and gets to the top, does it slide back down? So we want our force of static friction to be greater or equal to our tension, because if it was less than, the book would slide. So we know friction force is equal to the coefficient times the normal force, mg cos 30. So it's equal to 0.5 times 1, the mass, times 9.8 cos 30, 4.24 newtons. And our tension is equal to mc. Our tension is just the mass of cup. Since it's not moving anymore, we don't have to worry about acceleration, so our tension is just going to be equal to the force of gravity on the cup, so mass times gravity. And we know we get that to be 4.9 newtons, so the tension will pull it back down. Tension is greater than static friction, so the book will slide back. Different areas where you can mess up here is not converting 0.5 for the 500 kilograms, because 500 kilograms is equal to, or 0.5 kilograms is equal to 500 grams. Making sure that you're writing your coordinate system and you're keeping your signs all good, not equaling tension, not understanding that there's an acceleration in our tension. So we know our tension can't just be equal to the mass times gravity, because we have an acceleration. But that's why here we don't have an acceleration, so we don't add that in.